Hello and welcome to this lesson on desalination. In today's lesson, first, we'll explain why this process is necessary in areas with limited fresh water supplies. Next, we'll describe the processes of distillation as a method of desalination. Finally, we'll outline reverse osmosis as an alternative approach of desalination. So far, we've discussed the importance of potable water, safe drinking water, and how crucial it is for human survival. You're also well versed in the methods used for producing potable water, such as filtration and chlorination. Building on this foundation, today's lesson will deepen our chemical understanding by exploring how we can convert seawater into potable water using advanced techniques like distillation and reverse osmosis. This will show us how chemistry plays a vital role in addressing global challenges such as water scarcity. Let's get started. First, let's understand why desalination is necessary. In many regions around the world, such as arid and semi-arid areas, or even some islands, the supply of fresh water is either very limited or contaminated. This makes it challenging to provide enough potable water for the population. Desalination offers a solution. This is the process of removing salts and other impurities from seawater. This offers an alternative source of fresh water. It is crucial where natural freshwater resources are insufficient to meet demand. Now, let's explore the two primary methods used in desalination: distillation and reverse osmosis. In distillation, seawater is heated until it boils and turns into steam. Next, the steam rises, leaving behind the salt and other impurities which do not evaporate. The steam is then captured and cooled in a condenser, which turns it back into liquid water. Finally, this liquid water is now fresh and safe to drink, having had the salts and impurities removed. Imagine distillation as similar to boiling a kettle. The steam, which is fresh water, rises and you'd capture it in another container by cooling it down. The salts are left behind in the original kettle. In reverse osmosis, seawater is forced through a semi-permeable membrane under high pressure. This membrane allows only water molecules to pass through while blocking salts, bacteria, and other contaminants. As a result, the water that comes out the other side of the membrane is fresh and safe to drink. The remaining salty concentrate is then usually disposed of. Think of reverse osmosis as a very fine sieve. Only pure water molecules are small enough to pass through the tiny pores in the membrane, leaving the salts and impurities behind. Both distillation and reverse osmosis are highly effective in producing potable water from seawater. However, they are also energy-intensive processes. Distillation requires a lot of heat to convert water into steam, and reverse osmosis requires significant pressure. This high energy demand makes desalination quite costly, which is a major consideration when deciding whether to implement such a system. In summary, desalination provides a crucial solution for providing potable water in regions where it's otherwise scarce. Through the processes of distillation and reverse osmosis, seawater can be transformed into safe drinking water, though it comes at a high energy cost. In today's lesson, we discussed the necessity of desalination in regions with limited fresh water supplies, such as arid areas or islands. Desalination is essential because it converts seawater into potable water, providing an alternative source where natural resources are insufficient. We explored two primary methods: distillation and reverse osmosis. In distillation, seawater is boiled to produce steam, which is then condensed back into fresh water, leaving salts behind. Reverse osmosis involves forcing seawater through a semi-permeable membrane under high pressure, allowing only water molecules to pass through and blocking contaminants. Both methods effectively produce potable water, but are energy-intensive and costly. Overall, this lesson has highlighted how chemistry helps address global water scarcity challenges by transforming seawater into safe drinking water. Watch the rest of the GCSE chemistry course at Sophos Education.